Okay, so we're going to start from the packet that's finishing section 1.4 and section 1.5 where we left off on Monday. And so the note over here, if the graph of a function has an x-intercept at a0, then a is a 0 of the function. Okay, and definition, the 0 of a function of x are the x values for which f of x equals 0. Okay, so what that means is whenever you're asked to find the zeros of a function, you set that function equal to 0. Notice that's not the same as f of 0. Okay, so these two aren't the same because f of 0 would mean you set your input would be 0, so you put 0 inside your function. Whereas f of x equals 0 is you're setting your entire function equal to 0 and trying to solve for x. Okay, so in example 3, we need to find the zeros of f of x equals x squared minus 9x plus 14 over 4x. So we're going to take our function. So x squared minus 9x plus 14 over 4x and set it equal to 0. And now use some algebra. So we multiply both sides by 4x. And you'll have x squared minus 9x plus 14 equals 0. And then I'll leave it to you all on your own to factor that. So continue factoring that. That factors nicely. And your final answer would be 7 and 2. So what that tells us is that for this function, so the zeros, that tells us that the zeros are 7 and 2. But when we get into graphing functions, this also tells us that 7, 0 and 2, 0 are on our graph. Okay, so this next one, we have g of x equals the square root of 2x minus 1. Again, we need to find the zeros of this function. So you can take 2x minus 1, set that equal to 0. Remember what I said with square roots. If possible, isolate the root first. So let's add 1 to both sides. We get the square root of 2x equals 1. Then we can square both sides. And we'll get 2x equals 1. And then just divide by 2. So x equals 1/2. Okay, so now we're talking about increasing and decreasing functions. And we're going to go over those definitions. So for number 1, a function is increasing on an interval if for any inputs, let's call those inputs x1 and x2, with x1 being less than x2, f of x1 is less than f of x2. So graphically what that looks like is this. So we're going to have two values, let's say, actually, let me go back. I want to draw it first. So we'll have some picture like this. And this will be called our x1, and this will be called our x2. Remember, again, we read graphs from left to right, so you can sort of tell if you think of a car driving on this track, it's increasing. And this is f of x1, and that's f of x2. Okay, so we would say that f is increasing on x open brackets x of 1 x of 2, and it's open brackets because although you can see it's closed circles on the endpoints, when we talk about increasing, decreasing on constant functions, it's always open brackets because at those endpoints something special is going on, which you'll learn more about in calculus. It's called points of inflection, and so you'll learn more about that in calculus. We're not going to talk about this in this class, but I just want you to know that you always keep it as open brackets, and you always are looking at your x values when you talk about your input, your increasing, decreasing, or constant function. Okay. All right, so number 2, a function is decreasing. And I hope you can see that. Decreasing. Again, on any interval or in an interval if for any we still have x sub 1, two inputs, x sub 2, and x sub 1 is still less than x sub 2, but this time f of x1 is greater than f of x2. So pictorially, this is what's going on. You have, all right, and again, if you think of a car going on that track, you can tell that it's decreasing. So that's x sub 1, and that's x sub 2. And this time, this is f of x sub 2, and that's f of x sub 1. Okay, because f of x sub 1 is larger than f of x sub 2. So we would say that f is decreasing on x sub 1 and x sub 2. Okay. Okay, and so for our last definition, a constant or a function is constant on an interval if for any x sub 1 and x sub 2, f of x sub 1 equals f of x sub 2. Okay. And pictorially for this, we'll have Alright, I hope you can see that. And so that's x sub 1, that's x sub 2, and now f of x sub 1 equals f of x sub 2. I didn't have room to write it on the same line, but so they're equal. So in this case, we would say, so f is constant on x sub 1 and x sub 2. Okay, so example 7, we're going to do example 7 together, and then I'm actually going to have you try example 8 on your own, and we'll talk about it in class tomorrow, or on Friday, I should say. Okay, so here we have, for two graphs, state the domain of the function, the range of the function, and if applicable, state where the graph is increasing, decreasing, or constant. Okay, and I put arrows, so on your papers, you don't have the arrows like here or here on your graph. And I put those on there because you can assume, and you might see this actually on the homework, that don't assume it stops there. If it stops, that would mean it's a closed circle on the end of your graphs. So if it's not a closed circle, if it's just a line like your graph has, then that means that graph is going on forever in both those directions. So if you want, you can add arrows just so you'll know, okay, it's going on, and you'll remember that it's going on forever in both directions, but you don't have to. Just keep that in mind. Okay, so here, domain, again, we read our domain left to right because we're looking at our x values. We read our range bottom to top because we're looking at our y values. Okay, so the domain here is actually all reals. So you can say all reals, remember our notation for reals, or in terms of interval notation, you can say from negative infinity to infinity. That's another way to say all reals, all real numbers. The range, if you look from bottom to top, it's still all reals, so negative infinity to infinity. And we're increasing, so let's see. So actually, from negative infinity to 0, because remember, we're looking at our x values. So from negative infinity to 0, we're increasing. And union, because we're also increasing from 2 to infinity. Okay, and we're decreasing from 0 to 2. Okay, and constant, you just put NA for not applicable in this example. Okay, so now you're going to do this one on your own. Again, you can put little arrows on the end to say that's going on forever. So you're going to find out what's the domain of the function, what's the range, where it's increasing, decreasing, and constant. And we'll go over the solutions on Friday.